In this video, we'll understand how to use CAN in STM32 using a CAN transceiver. Here, we are using transceiver SN65HVD230. There are many transceivers models available online, but I'm using my own board for this video. Okay, let's start with a project creation. Let's select the controller STM32 F103. Click on next, your project name, finish. Now we'll select serial by debugger here. Next, we'll be selecting uh, CAN in connectivity. Go to connectivity, select CAN, activate it, and here uh, I'm going to use 5500 kbps. So to get 500 kbps, we have to adjust prescaler and time counter in bit segment 1, time counter in bit segment 2. Here I'm using a prescaler as 1, and so time counter in bit segment 1, I'll be setting it as 13, and for 2, I'll be using it as 2. It will be different for different borders and for different controllers. Select it based on your application. Now enable the retransmission, and if you see here, the TX is that PA12 is a transmission pin, PA11 is a reception pin, and this pins needs to be connected to the transceiver. So transmit connects to CAN TX, receive connects to R pin of a transceiver, and now save the code, generate, save the configurations, and generate the code. Basically, here we have to create two functions. One to configure the filter, and another one is to broadcast the CAN messages. So we are using CAN send function to broadcast the message and CAN filter config for filter configurations. Now in user begin for part, we'll just write definitions for these functions. So all CAN drivers provide us some structured type diffs. We are using one structured type diff here, which is CAN filter config type diff. So I'll name the variable as filter. We'll add each parameter and configure each parameter here. So if you do a control click on that variable, you can see all the members in the structures. And now we can start. So for filter activation, making it enable. For filter bank, I'm selecting bank 0. FIFO assignment, I'm using FIFO 0. Mm, we have to select mask IDs, ranges also, and also ID ranges. We are using only one ID, so I'm making everything as 0. It will just look for a particular ID. So I have given mask ID high as a 0, low as a 0. Next, we are going to select the mode. So I'm going to use a filter ID mask. The next is a filter scale, and I'm using a 32-bit scale. Next, Haldor has provided a function to configure this filters. So I'm using this hall can config filter, passing out the can handle and the filter variable. Next is the broadcast function. Since we are only transmitting, I'm just creating a TX header part. Here in this header, we'll have store some information regarding data, CAN ID, and other things. So to store the data, we need a buffer. So I'm just taking some random data like 0x11, 0x22, 0x33, and 0x44. to transmit the data. I'll be sending only just 4 bytes. Taken 4 bytes, remaining bytes I'm making plus 0. Next, we have something called mailbox. So we have to create a mailbox variable. And using mailbox, like we'll broadcast this messages. So taking this header variable, updating data length count as 4. And next variable is IDE, whether it is a standard ID or extended ID. I'm using a CAN standard ID. Next, I'm using RTR, whether it is a remote frame or not. So the remote frame CAN RTR. Next, I'm giving a ID for the our CAN message. So I'll take just some random 321 as an ID. This one transmit global 10 and just disabling it. Next, uh, we have a function in hall driver to broadcast this message. We'll just add a message to this mailbox, which will broadcast the message. So the function for this one is all can add tx message, add handle, header, data, and mailbox variables here. Just pass these variables. If this is not okay, if this call fails, it will call an error handle. Means we have to call this function from the main function. Just initially we'll configure filters. We'll call our function. Then we'll start the CAN peripheral. Then we'll be broadcasting the CAN message every 1 second. So we'll use our CAN send function and we'll call this with a 1 second delay. We'll build this project, we'll flash the code, and we'll see how the response will be using a logic analyzer on the canvas. This is logic analyzer data. If you see, it is broadcasting messages. And if you see here, the identifier is 801 in decimal. If you convert 801 in decimal and hex, it is 321. So if you see our identifier is 321, so our identifier is matching, and our data bits bytes are 0x11, 0x22, 0x33, and 0x44. If you see in the logic analyzer data, it is ASCII 17 double quote, ASCII character 3, ASCII character D. If you open ASCII table, hexadecimal 11, hexadecimal 11 is decimal 17, and hexadecimal 22 is double quote, hexadecimal 33 is ASCII character 3, and hexadecimal 44 is character D. So even the data is correct here. So this is a simple introduction to CAN on how to broadcast CAN messages using STM32 controller.